based on the assumptions number one, in a solid, the atoms do not vibrate independently with same frequency. With same frequency. The first assumption on the basis of which debay put forward his model of specific heat is that atoms within the solid do not vibrate independently with same frequency. However, atoms are coupled. Atoms are coupled and are treated as and may be treated as coupled harmonic oscillators. Coupled harmonic oscillators. So atoms within the solid, they do not vibrate independently, but they are treated as coupled harmonic oscillators. Coupled harmonic oscillators. They are treated as coupled harmonic oscillators. So, this was the first assumption given by debay on the basis of which he has formulated his model of specific heat. Second is that the frequency of one mode of vibration is different from the other mode of vibration in the solid. Other mode of vibration. This is the second postulate on the basis of which this whole theory was developed. First is that the frequency of one mode of vibration is different from the atoms are treated as coupled harmonic oscillators. The second one is that the frequency of one mode of vibration is different from the other mode of vibration. Third, in a solid, there are limited number modes of vibrations. Or number of modes of vibrations in a solid are limited in number. Number of modes of vibration in a solid are limited in a number. So, fourth one is that the solid may be, this is an important one, the solid may be considered as an elastic body. It may be treated as an elastic body having transverse as well as longitude. That means the solid may be considered an elastic body so that the stationary waves in the form of longitudinal and transverse waves are set. So that transverse and longitudinal waves are set. When you treat any body as an elastic body, due to its elasticity, it can have either transverse motion or it can have longitudinal motion. That means this solid may be considered as an elastic body, so that the nature of the waves that is being set up within the solid may be of either transverse nature or longitudinal nature. Fifth one is that in a solid, the total number of modes of vibration is 3n. 3n is the total number of modes of vibration. So sixth one is the maximum frequency. The maximum frequency F maximum is equal to FD is called debay frequency. ये आप क्लोज कर दो दरवाजे को, आप कुंडी लगा दो. Is called debay frequency. So let me remind you again. So this debay model is based on what you call I have written here 6 assumptions. This debay model is based on 6 assumptions. First assumption is that yes,
harmonic
the
oscillator.
atoms are treated as coupled harmonic oscillators, as I showed in the figure. They are treated as coupled harmonic oscillators. Okay? Second is that the number of modes of vibration, the frequency of one mode of vibration is different from the frequency of another mode of vibration. Third is that in a solid, number of modes of vibration are limited in number. And the fourth one is that the solid may be treated as an elastic body. Once you treat a solid as an elastic body, that means either it can have transverse motion or it can have longitudinal motion. That means it may be comprising of 2 types of motions, longitudinal as well as transverse motions. And the fifth one is that the total number of modes available is 3n. So the maximum, sixth one is the maximum frequency. F max is equal to FD, which is known as debay frequency. This is known as debay frequency. Okay? Now let us try to solve this problem. Okay? So we are choosing some frequency range F and F plus df. F plus with some increment F plus df. So therefore we like to find out number of modes of vibration. Number of modes of vibration in the frequency range. In the frequency range F and F plus df. So it is represented by T of F. T of F gives me the number of modes of vibration. It is equal to 4, we know it is represented by the equation 4 pi V by V cube F square df. Why this is equation 1? This is the equation that is representing our number of modes of vibration in the frequency range F and F plus df. So while your V, capital V is nothing, it is the volume of the solid, and your small v is velocity of the wave. But this V can have 2 types of motions. Either it can have transverse motion or longitudinal motion. Okay? There are two types of motion. The propagation of wave, because v is the velocity of the wave or wave velocity. The propagation of the wave through any medium is transverse as well as longitudinal. But one important thing is that for transverse motion, you are having two types, two modes, or I will use the word modes, two modes. See, if you pull up a string, in between in such a manner that the particles can either move along vertical direction or horizontal direction. So you are having two ways to express the transverse wave, but you are having one way to express the longitudinal wave. You are having just one way to express the longitudinal wave, but you are having two ways to express the transverse wave. Okay? So because the particles, if you plug a circling, the particles can be either they can be either vertically or horizontally to the direction of propagation. So you are having two ways of expressing the transverse wave. Then how this equation 1 will take form, we will see. So you are saying that propagation of wave through medium is of two types. One is longitudinal and another is transverse. No, it's a plate over. And transverse wave. So these are two types of waves that are being produced. That the propagation through of the waves through a medium is of two types. Through medium is of two types. But transverse wave has two ways to propagate. But transverse wave has two ways to propagate. So you will ask why I am writing this much, why I am explaining this. Because I have to modify equation 1 in such a manner where I can express Vt. If I represent Vt is the transverse wave having two modes and VL having one mode. See how I can write this equation. So equation 1 can be written as d of f is equal to 4 pi capital V. I am writing 2 by Vt cube. 2 by, because transverse waves have 2 by Vt cube and longitudinal wave is having 1 by Vt cube. One way of expressing and two ways of expressing through medium. Okay. Plus 1 by VL cube into F square df. Your naming is that equation 2. So basically I have expressed V, which is the velocity of the wave, by transverse nature as well as by longitudinal. For transverse nature, I have written 2 by Vt cube because of the two ways of propagating it. And for longitudinal wave, I have written 1 by VL cube. 1 by VL cube. Are you getting what I am trying to convince you? No.
Two ways or two modes.
See, one is two types of waves. When a particle, when atomic coupled, when coupled atomic oscillators oscillate, they can have transverse as well as longitudinal modes of vibration, waves of motion. So the waves that can propagate through the medium are of transverse and longitudinal nature. But your transverse is having two ways of expression. So it will be having further two ways or two modes or two types. So I am writing 2 by Vt cube or this 1 by V cube. 1 by V cube, 4 by V I am taking out. or this 1 by b cube, to represent it, to differentiate it from the longitudinal wave velocity, I am writing it 2 by dt cube and 1 by dl cube, and there is f square dm. So, what will be the average energy? So, one thing is there.
3n.
F maximum is equal to average. I have given a supposition that maximum frequency of this coupled harmonic oscillator is debay frequency. F is the frequency. F is just like you are representing it by nu, here I am representing it by F here. So F is the frequency. The maximum frequency is basically debay frequency. The maximum frequency is basically debay frequency. So you can have, so that means 0 to F max. 0 to F max is df is equal to 3. What are the total modes of vibration? See, we are writing this as number of modes of vibration. This represents df, basically represents number of modes of vibration in the frequency range f and f plus d. df, I am again repeating, df represents the number of modes of vibration in the frequency range f with small increment f plus d. F plus d. But this f maximum is the maximum frequency. So, debay frequency. So, in that case, I am giving the limit. So, if you calculate the total number of modes of vibration. So, you have to integrate. Suppose if this table, somebody will ask you what is the total area of this table, it is going up to infinite. So you can take out one rectangle from it, x dx, you can get one integral, then x2 dx2, x3 dx3. So y dx, y1 dx1, y2 dx2, y3 dx3, y4. So you can write 0 to infinity y dx. That way you get the area of this thing. Similarly, the number of modes of vibration are this thing. So what are the total number of modes of vibration? Integrating this factor. df with df, 0 to maximum. Maximum is the range up to which you can go in the frequency. Your coupled harmonic oscillators can have maximum frequency f max. Not beyond f max is the maximum limit for your frequencies. So you can just integrate this factor, but this is equal to how much? Because you are asking total number of modes of vibration. But total number of modes of vibration available in the solid is 3n. That I have given the assumption 5. Is it assumption 5? If you look at your copy. Assumption 5 that you have jotted down it earlier. So, maximum nodes, total number of modes of vibration is equal to df 3n. Now that means you have to substitute this value in this integral, then you can calculate the total number of modes of vibration. So how to do it? So 0 to f max. 0 to f max. So f max is not a name of some hero or something like that. Okay? As you see in Hollywood films. It is 4 pi v, 2 by vt cube plus 1 by vl cube. vl cube. It is f square df is equal to. Up to that point, is it fine? Okay. Shall I write it now? The equation 2, but you remember equation 2, we will be replying it later as well. Now we will try to get the average energy of an harmonic oscillator. So that implies 4 pi v. It is 2 by vt cube, because these are not dependent on df. These are basically the constant. We have to take out these factors. Plus 1 by vl cube. So inside the integral you are having 0 to f max. 0 to f max. And you are having f square
df
is equal to
3n.
That implies your 4 pi v pi v 2 by vt cube plus 1 by vl cube. What is it? Will be f max. F max cube divided by 3.
Yes,
That will be integration of it. इसकी इंटीग्रेशन यही होगी ना. So that means I can write in another way 4 pi b 2 by vt cube plus 1 by vl cube, which is equal to f max cube into 9n. But what is f max? F max is equal to FD. F max is equal to FD. Maximum frequency is basically the debay frequency. Maximum frequency is basically debay frequency. That implies 4 pi b 2 by vt cube plus 1 by vl cube is equal to 9n by f d cube. Can I write it this way? Can I write it this way? Now, what we are actually interested, because we have to find basically the specific heat. We have to find the specific heat. For specific heat, we need to have total energy of the system. But for total energy, we will have like first to get the average energy. Therefore, average energy associated with atomic coupled harmonic oscillator is, so it will be E bar. It will be E bar. E bar will be equal to
H
hf by e raised power hf by kT
minus 1.
hf by kT minus 1. What will be your total energy? Your total, this is average energy. Names an equation. This is equation 3. This is equation 4. This is equation 4. Okay? Total energy U will be equal to
Integration of
0 to FD. 0 to FD
E
d of f hf by e raised power hf by kT minus 1 into df. That will be your total energy. This is the how you get the average energy. You have also tried it in quantum mechanics paper. How you are finding the total energy of the system once your average energy is given. So your total energy is df. That is the number of modes of vibration.
Yes, sir.
Into the average energy associated with each coupled harmonic oscillator. Okay. But you remember equation 3. It is of my help here. So name this as equation 5, if I remember correctly. So what is your internal energy U? It is equal to 0 to FD, because FD is the maximum frequency now. 0 to FD. What is df? df is 4 pi v 1 by vt cube plus 1 by vl cube f square
what
f square into hf divided by e raised power hf by kT minus 1 df.
यहाँ पे 2 modes of energy.
और कुछ आएगा?
2 VT cube.
2 by where is 2 by?
2 modes of ये है ना वाइब्रेशन ट्रांसलेशन में यहाँ पे फार्मूला.
अच्छा आया 2 by dt. Okay. This is equation 6. This is equation 6. So your total energy U will be equal to 4 pi v 2 by vt cube plus 1 by BL cube inside the integral you will be having h you will take out, this h you will take out, this h you will take out. Inside you will be having f cube by e raised power hf by kt minus 1 df. Name this as equation. Okay, one thing is there. This is equation 7. Using equation 3 in equation 7. So इस portion के बदले में दे दूंगा I will substitute the value 9n by FD cube. You see the equation 3. So look at equation 3. For this portion, total energy U is equal to, it is 9n by
4 by
FD cube. 9n by FD cube. And there is H is there. Then this is 0 to FD. F cube e raised power hf by kt minus 1. But let hf by kt is equal to hf by kt is equal to x. hf by kt is equal to x. hf by kt is equal to x. That implies kt by h. Okay. H FD, but f is FD by kt is equal to x. But FD is when x is maximum. FD is the maximum frequency. At the time your x will be maximum. So that means or FD is equal to kt by h x max. This is the one condition. This is the second condition is when f is equal to 0. When f is equal to 0, at that time from this equation kt by x is equal to 0. At that time your x will be 0. Your x will be 0. Which why you want someone to catch this? Are you getting what I am trying to do here? Because I have to change the limiters basically. So see, I have taken this hf by kt is equal to x. But if I am replacing f by fd, at that time x will be having maximum value. Because fd is the maximum frequency. So fd is equal to kt by h x max. Now I am taking the second condition when f is equal to 0. When f is equal to 0 in this equation, kt x divided by h will go down. F is 0 for fm, the value 0. From this equation, so you can write down it this way: kt by h x is equal to f. But you are treating f 0. So kt by h x is equal to 0. At that time x is 0. Now when f is equal to fd, if frequency is maximum, at that time you will be having kt by h x is equal to x max. Instead of f, you are having here 0, but now f is fd, it is then x will be equal to x maximum. At that time your x is equal to x max. This is very, very important to understand this problem. So this is the crux of this derivation. You have to understand that. So again, do you want I should repeat it again?
yes sir.
Come. It is kt by x. No, but see, this will be having f maximum value. F maximum value will be at the time of when x is equal to x maximum. That's why I am writing here x max. I am writing here x max. See, I am again trying to make you understand. df. Okay. dx is equal to dx is equal to dx is equal to h, okay, here hfd by kt is equal to d times df is equal to kt by h dx. Can I write this way also? By differentiate this equation. The equation can be differentiate. We also require this thing because we are at a df factor. So my aim is to get rid of this thing in terms of dx. मेरा एम ये है कि इस इंटीग्रल में मुझे df को रिमूव करना है in terms of dx और मुझे जिसको थीटा डी बाई टी थीटा डी में इसको कन्वर्ट करना है एफडी को मुझे थीटा डी बाई टी में कन्वर्ट करना है. उसके लिए एक तो ये सारी कंडीशंस मैंने अप्लाई की दैट आई एम एबल टू अंडरस्टैंड understood. Third, second thing is that I am differentiating this. I am taking f is equal to kt by h x. It is, if you differentiate, df is equal to kt by h dx. So that means here I can insert this value easily. This value can be easily inserted here, and for this I can also look for other values. Shall I rub this? Now the equation 8 becomes equation 8 क्या बन जाएगी? जरा मुझे कोई बनाया बताएं. सी हमारे पास था बिफोर दैट आई कैन राइट डाउन थीटा डी एच एफ बाई के इज इक्वल टू थीटा डी. ठीक है? सो दैट इंप्लाइज एच एफ बाई के टी इज इक्वल टू थीटा डी बाई टी. थीटा डी बाई, बट व्हाट इज दिस कंडीशन? X max. This condition is at X max. This condition is at X max. Or you can write represented by FD as well. Okay? This condition is at X max. Okay? So your equation 8 will become total energy will become. See, don't talk, don't have any conversation. 9n by here FD cube is I can write down here FD cube first, then h, then 0 to theta d by t, f cube. What is f now?
kt
F is kt by
h into x.
kt by h cube.
Yes sir.
kt by h cube. Then there is 1 by this part, 1 by e raised
X.
power
x
theta d by t, theta d by t. क्या है? थीटा डी को kt by h मगर स्विच है t थे, स्विच है t थे. यहाँ तक समझ में आ रहा? So e raised power theta d by t minus 1. लेकिन and you are having df. For df you are having kt by h dx. So now we'll try to find out the answer. For this FD we'll also make substitution. So u is equal to 9n by FD cube. What is FD cube? FD was what is FD cube? Yes? kt by h. kt by h. I can write down here kt by h का
whole cube. या हम
Exact.
लिख सकते हैं h डिवाइड बाई kt.
x max kt by h का cube. Okay, I'm trying to check it out. H into kt by h and again you are having kt by h का whole cube. kt by h का this kt by h का whole cube h kt by theta d by t, then you are having inside, you are left with ktx is here. ktx. ठीक है? kt by h x. ठीक है ना? तो अंदर रह जाएगा x क्यूब by e raised to power x minus 1. e raised to power x minus 1. अंदर रह जाएगा अब और x क्यूब टोटल आना चाहिए. kt by अच्छा ये था ना dx x का क्यूब है. ठीक and dx. This will be within the integral. Now this h and this h will go. This h and this h will go. Clear of it?
Yes. Grown over.